Ladies and gentlemen, I am the group leader for Lab Fluid Mechanics first experiment, and that is the stability of floating bodies, experiment 1. So these are the contents, which are a report summary and theory going to be presented by me, Mohammad Haikal. Experimental procedure going to be explained by Shafiq. Raw data analysis and conclusion is going to be explained by Afan. Results and discussion is going to be presented by Afiz. So let's get onto it. So the first one is a report summary. So experiment 1 for fluid mechanics is the stability of floating bodies. The aim for this experiment is to find the height of the metacenter by using the tilting method. In this experiment also, we need to determine the center of gravity, which is CG, metacenter being GM. The equipment used in this experiment are 5 things, which are ruler, a pontoon stabilizer, a pontoon, and pillar with horizontal and vertical weight, and also a water tank, which is 5 in total. There are 2 values that affect the height of the metacenter of a medium. Those are the movement of the horizontal from right to left. We can also call this the changing variable. As we change the values, there is something that needs to be observed. That is the angle of tilt of the thread from equilibrium. This is the observed variable. After acquiring both of these variables, we will use them in equation 3, explained in theory, to find the height of the metacenter. So next is about theory. A floating body can still be stable even if the center of gravity is overhead the center of buoyancy, which is center of gravity, buoyancy. Okay, when the body starts to rotate, the buoyancy force will act on the center based on the volume displaced in the water, and thus a restoring couple to try counteract this displaced water will try to return to its original position. However, for mediums that are actually tall, which is tall, have low base, small base, even with a small rotational displacement, even if it's a little, can cause an overturning due to the buoyancy force and the weight of the medium, which will make the floating body really unstable. Throughout this observation though, the stability of the pontoon is to be found with the center of gravity at different heights or distinct heights. When a horizontal weight is moved from a distance x, which is from left or to right, from the center of the medium, which is 0 tilt, tilting will actually happen. By using the plumb bob, an angle of the tilt can be determined. Equilibrium condition can be found out experimentally by overturning couple CO is equals to mgx, which is equation number 1. Writing couple CR is equals to mg gm tan theta. Equilibrium condition equals to CO equals to CR and also GM is equals to Wx over capital W tan theta. Equation number 3. W is given inside the experiment, and capital W is a constant. Results obtained experimentally must be compared with a value that is theoretically founded, which are dm equals to 1 over v, I is equals to lp cube over 12, equation number 4, and and the standard density equation, a formula. Gm is equals to Bm minus Bg, which is then derived into Bm minus Y plus D over 2, which is equation number 5. So next is going to be about experimental procedure, which is going to be explained by Shafiq. Now.
So I will describe the experimental procedure. Number 1. Horizontal weight was removed and the head of the vertical weight on the mass of the pontoon was fixed. Number 2. The center of gravity then was determined by putting the pontoon mass on the pontoon stabilizer. The length of center of gravity, which is the half distance from the base of the pontoon to the center of vertical weight, was measured. Number 3. The horizontal weight was fixed and the thread was ensured at 0 millimeter position, which is no tilt. 4. The tank was filled with water and the pontoon was placed in the tank. Number 5. The length of the pontoon, which is submerged in the water, was measured. Next, the horizontal weight then was moved 10 millimeter to the right, and then the angle of the tilt of the thread was recorded. Next step number 6 was repeated by moving the horizontal weight to the right with 10 millimeter increment. The angle of tilt was measured, and this step was repeated until the plumb board, which is hanging, touched the side of the pontoon. Then step number 6 and 7 were repeated by moving the horizontal weight, and this time to the left. Lastly, the head of the vertical weight was adjusted to a new head, and step 1 to 3 followed by step 5 to 8 were repeated. This test for 2 different values of vertical heads were done.
Okay, hello, my name is Muhammad Afan, and I'm going to present the raw data and analysis. As we can see, this two table is shows for test 1 and test 2 with a different value of center of gravity, which is for test 1 is 132 millimeter for the center of gravity, and test 2 is 194 mm. Next slide. Alright, this one is for test 3, which is the value of center of gravity is equals to 80 millimeter. So this data that we obtained from our previous experiment, and the question asked for plotted the graph GM versus theta. Next slide. Okay, this one for graph for test 1, which is GM versus theta, and when the theta is equals to 0, the value of GM equals to 34.9 millimeter. Next slide. Alright, for test 2, when theta equals to 0, the value of GM equals to 70 mm, and for test 3, next slide. For test 3, when the theta equal to 0, so the value of GM equals to 93.7 millimeter. So for the detailed explanation of result and discussion, I will pass to Hafiz. Thank you.
So I will continue about the result and discussion part. So based on what Afan has said earlier, based on the graph, when theta is 0, the center, the GM for test 1 is 34.9 millimeter. For test 2, the GM is 70 millimeter, and for test 3 is the GM is 93.7 millimeter. By comparing the data obtained, as the CG decrease, the GM will increase. We can see from when CG is 100 millimeter, the GM is 34.9 millimeter. And when in test 2, when the CG is 104 millimeter, the GM is 70 millimeter. And for the test 3, when CG is 80 millimeter, the GM will be 93.7 millimeter. So theoretically, when the pontoon mesh is symmetry, the angle of tilt of thread due to the shift of weight to both sides should be almost the same, but this could not be achieved as there are something errors during the experiment. So this is the formula for GM, which is LB cubed over 12 times density over W minus Y plus D over 2. From what we calculate for test 1, 3, this is the value that we got. For test 1, the GM is 80.671 millimeter. for test 2, 109.171 millimeter. For test 3 is 133.671 millimeter. So this is the point for the reliance of the meta center on the position of the center of gravity in terms of stability of a floating body. The first one is the meta center, GM, depends on the position of center of gravity, G. If the meta center located above G produce a righting moment, equilibrium is stable and GM is considered positive. But if M is located below G and overturning moment is produced, the balance is unstable and GM is considered negative. The last point is the equilibrium will be neutral when M coincides with G. Next, Afan will continue about the conclusion part.
Okay, as for the conclusion, by this experiment, we made it to determine the metacentric height and the change of metacentric height with the angle of tilt. So by using three different heights as shown in the result just now, so we determine the stability of floating bodies in stable or unstable condition. So when the position of the curve is added, the value of angle is increased as well. This makes the floating bodies become unstable from time to time. So it means that when the gravity increase, then the metacentric also increase, and when the angle of tilt increase, and the metacentric will increase as well. And the data obtained is, however, the data obtained is slightly different with the theoretical value. This is due to some error that we need to overcome. So firstly is we need to avoid parallel error during taking the point of reading, and the next one is we should always repeat the reading and calculate the average to avoid the random error. And the last one is we should make sure that the pump box stop before taking the point reading. Okay, that's all. Thank you.